Okay, this video is a discussion of the DataFrame's data structure in the Pandas library. Again, I'll use my notepad to lay out what I discussed, the big picture that I discussed in the previous video on the series data structure. So the Pandas library, import Pandas as PD, and I said one of the, and this is probably the key data structure, is the data frame, and this is a table-based or tabular data structure, and you can visualize each of the columns as being a series object. So it's basically a set of so each column would be a series object. Okay. And so I'll get some specific data from, this is the example I've used, there's some census data, and so I have, so let's see, I'll use some of these, like the state name, the county name, the census, 2010 population, some of these columns. So let's say I use those three. So my first series would be state name, my first series and the first column. The second is the county name. Then the third is census 2010 population. And it has some estimate for 2010. So we will go through some of that. Actually, what I will show you is also how to just reduce the, it has I think about, as you can see, 100 different columns here in this CSV file. Typically you're going to create your in most real-world applications, you'll be creating a data frame by reading from an Excel or a comma-separated file. In this example, and for your homework, you'll be using a CSV file. One of the things, the reason I didn't quite start a new notebook was that I wanted to make sure I'm in Module 4. I'm starting my notebook from Module 4. Make sure that your CSV file is in that directory. So Module 4, I have my census.cs, my census CSV file. So when I start this up, I'll just call this it's the Pandas data frame discussion notebook. Okay. So I want to make sure that when I import, and again there are you can do a series of things, but I want to, the first thing I need to do is to import Pandas as PD, and then I can run this, and then I can say I want a data frame. I can give some specific name, but to reduce the amount of typing and make this a little faster, I'll say pd.read CSV is the name of the method, and then I will have to give the name of the of this CSV file, which is census.csv, and to just make sure that it has read in, you can use the head method on the data frame. So df dot head and open close parentheses. Anytime it's a method, you would you see this open close parentheses, and in this case read CSV has a parameter which is essentially the name of the file from which it is reading the data. Okay, so if I did this, you can see that it comes up with the first 5 rows, and then there are literally 100 columns. And for the homework, and let me very quickly go open up the need to open up the I want to show you the homework assignment, eCampus. So let me go there and show you what I have done with this with the homework. So when you're reading in some of these file names, if I directly go in and open up census, you'll see that it has some of them could be really they could have all kinds of extra characters. This census doesn't have so much of it, but the homework assignment that I've given the World Health Organization CSV file has all kinds of special characters. So let me see if I can show you some of them. Like you can see within parentheses percentage, and then there are others which have all kinds of other extra characters in there. So to help with that, on the Pandas question, I have also associated, so assignment 2 question 2.html. If you open that up, it's basically I've given you a set of statements to as to how you restrict the number of columns, and this is what I said. You have to, if you don't get the name exactly correct, then it's not going to find that column in the CSV file. So we only want like 3, 6, 9, 11, I believe it's 11 columns, which are of the several, I guess it's at least 100 different columns. So we are going to, how do you structure it, or what commands do you give to just keep that limited set that you want to work with? And also it becomes harder to work with a column when it has all these types of different characters. So how do you rename it? So that's what's in this HTML file that's associated with this question 2, which obviously you can use for, I didn't want you to be spending too much time trying to figure out the exact characters that are there. Okay, so that's just a quick note that I wanted to make you aware of when you're working with this the DataFrame assignment. Let me get back to this discussion. Let's see, DataFrame discussion, and also going to this notepad. So I'm going to have a set of series objects, each one a series object, which constitutes each of the columns, and then I'm going to, by default, have integer index. Okay? Later, I'm going to use the county name. So initially, it's an integer index, and then I will reset this to a label index, and the label index will be, so I'm going to reset it to a label index, and the label index will be the county name. Okay, so So these are some things we will do. So, and just again to remind you, if you go through this series discussion and understand how to use the indexing and essentially call it indexing, searching, selecting items in a series, and if you understand how you work with NumPy, doing various search operations like search and Boolean logic operations on NumPy, if you can combine these two, then if you understand those two, then working with the DataFrame becomes much easier. Okay, let's go back to the code. Okay, and here I want to restrict it to a smaller number instead of this 100 columns, so I'm going to use this columns to keep. So again, I don't want to type everything from scratch, so I will take these columns to keep. DataFrame discussion. Okay. This, if you don't have the spacing, it will cause errors. So Python is the white spaces are considered very important. So if you do any copy paste from the HTML file for columns to keep, just make sure that it is properly spaced out, and if you have an error, it's probably due to that. Okay, and then I'll just say the data frame is going to be consisting of just these columns that I want to keep, and then I will try to display the head so that I can see the head of the data frame, so I can see whether my columns to keep has taken effect. And you can see now that it's a much smaller number of columns compared to the 100 columns that were there when I read it in from the CSV file directly. Okay, now the next thing that I want to do is to do the navigation like we did with the series object. So if you remember from the series object, the way we navigated was by using lock and iLock. Okay, so these two the indexing operators or attributes, properties that we applied on series is usable with the data frame. The data frame is referred to as df. So I'll use iLock on it, and I'll say, well, give me the second index item, or the, I'm sorry, not the second, the index with the value of 2, and if I just did this, it comes back with all of the columns. So I guess there are 10 or 11 columns, so it comes back with values in the second row for all of these 11 columns. Now I could slice it by saying df.iLock in the second row, but I don't want all the columns. I want to start with the first column and go up to the fourth column. Okay, so now it gives me, starting with the first column, the second row, first column is Alabama and goes 1, 2, 3, 4. So I've said go up to the fourth column, which is going to be 1, 2, 3, 4. The births for 2011 is going to be 2,187. So that's what you have here. So those 4 columns in the row with the value 2, and since it's a zero-based index, the row with the value 2 is the third row. Okay. Let me keep track of time, so I don't want to keep going too long. Okay, it's already 15 minutes. Okay, so let's see. The next thing I want to do is use df.lock, and if you remember, lock is the label-based index. So if I said the same thing, if I wanted to display the values in the row with label 2, if I ran it, it does find it and come back. But if I said, well, show me the values in the second row, but only columns 0 to 4, it's going to tell me it's an error, because if you remember, lock is a label-based index, so if it will not work with integers if there are labels. It will work only if the integers are serving as the labels themselves, as they are in the case of the rows. But in the case of the columns, they actually have labels and not just the integers to indicate the column. So while this is 0, 1, 2, 3, 4, as far as the labels are concerned, 0th label is st name, and if I want to go 1, 2, 3, 4, the fourth one is births 2011, and as far as I know, it's case sensitive, so I have to give it exactly as is in the column label. So if I run this now, actually, I obviously wanted to do this here. So this one was 0 to 4. I'll just take this from here, put it in lock. I didn't want to do it in ilock. In the equivalent of ilock is what I'm trying to accomplish. 4. Okay. So if I run this now, I get these the same result as with what I got with ilock previously. So ilock works with integer values, both on the rows as well as the columns, okay, across here. And while if you look at at lock, it works with the if there is no label for the row index, it goes with the number, but for the columns, since they have names, you have to specify the column labels or names rather than just the numbers. Okay, and let's also, I said that it is made up of each of them. So let's see how can we do this. So if I wanted to get just the column name, let's see if I can just display this alone. Okay, so that is not something I can get. I'll have to specify. So let's see, I specify the row. I can get this if I want the column. So anyway, so if I wanted to display just the column alone, let me try to do it with directly indexing it into it with st name. Okay, so now I get the column which is well, all the state names. It goes on down here, and let's see what is the data type of this when I do this slicing here. Okay, so what I told you was, if you look at this, the picture I drew, each one of these columns here is a series, right? So state name, when I sliced it out and looked at the type of the slice, it actually shows me that it's a series. Now let me try to slice out the type of a row, and remember that I got a row by using iloc of 2. If I do this, it basically gives me the entire slice of that particular row. So it's going to be row number 3, labeled, which is just the label 2. So if I did a type on this, that also comes back as a series. So essentially the entire data frame, however you slice it, if you slice it by column, each one is a series. If you slice it by row, each of the rows is also a series object. Okay, so that's why it is really useful if you study and explore the series object. It tends to help with working with the data frame. Once you have this, I think the other piece that I want to, well, before I move on, I do need to show you how to set a label index. So I want to set index, and this is the county name is what I want to set as the index on this data frame. Okay, so if I do this, you can see that it's no longer having the integer index, but it has a label-based index. So if I now do a df.lock, remember this is a label-based index. If I say lock2, if I run this now, it's the reason it's coming back is if I go back to df, it continues to have an integer-based index. Now you have to understand what's happening here. The df was not changed; it just was shown over here, and the only way it gets changed is if I reassign the value of the variable df. And the way you do it is to say df is now assigned whatever I have on the right side, which is with the new index cty name. Okay, so if I did this, I'm now permanently resetting whatever was on df's index. Now if I run df, I should get the city name as my label-based index. You no longer see 0, 1, 2, and so on, my integer-based index. Okay, now if I try to do what I did, to say df dot the label-based index, and I say now find me number 2, which earlier was 0, 1, 2, Baldwin County was location 2. Now if I try to run this, I get an error because there is no label value 2 anymore. So location is saying, well, I can't find a label with value 2. So if I want to find that, I have to look at Baldwin County as the index value. Okay, so now if I do it, it comes back with, is there more than one Baldwin County? Okay, so there's one Baldwin County in Alabama, another in Georgia. So it basically came back with the index values saying that there are two, and then it gives all of the columns for those two rows. Okay? I'm already at 25 minutes, but I want to discuss one last piece before I move to just this is using the where clause and doing searches. So so if I want to do a search for all the states which have let's say which are in the state of let's see, West Virginia, all the I want only the data pertaining to the state of West Virginia. Then I say df dot. This is like the SQL statement, the where clause. For those of you who are familiar with SQL, there are shorter versions of how you can create these queries, but I want to show you what is, I think, more understandable, especially if you can connect it to SQL. So I'm going to say, look at the column in the data frame called state name, and where the state name value is West Virginia. Okay, so if I did this, you'll see that I come back with the result is it shows essentially null values for wherever this condition of the state name was not West Virginia. So if I scroll down, you'll see that where I have, where's my state name? I even have the data here, the state name. This West Virginia. It might be even further down that I can't see it. So maybe I should go with a state that is more visible. So I'll just go with Arizona here. And this is the first state is Alabama. Let's see. Okay, I don't want to keep spending too much more time here. Instead, I'll go back to my slides so that I can use that for this discussion. This is what I've posted, the document. So instead of spending too much more time, the queries that you will be creating are queries like this. Okay, so you have to apply the where clause, open up the parentheses, and then apply the conditions. So df data frame on this particular column, I'm setting it the state name to be Alabama, and and I want the county name to be Baldwin County. If I want to apply multiple conditions, one of the things you have to be very careful about is for each condition you want to open, close parentheses. Okay, so you don't want it to be where you just have the two conditions combined with just the ampersand in between. So for the AND operator, you use the single ampersand. For the OR operator, you use it is, I think it's called the pipe. So it's just above the backslash, so it's like it shows up on the key like this. So this is the OR operator, this is the AND, and then this tilde is the NOT logical operator. So I've given some examples in both in NumPy and in this DataFrames example. Now, when you run this, you will see that the columns and rows which don't meet the condition have these null values, which are represented as NaN. So we want to get rid of those null values, so you would use the drop NA method. So if you say df.drop NA, basically gets rid of all those NaN values and just keeps the ones which actually meet the criteria. For your homework assignment, I want you to create a set of methods. So let me see if I can get to here. Okay, so I want you to create a class called WHO Statistics, search by continent or country. So you have to send in basically two parameters which are both optional, so you have to set it to none, and then do your search and return a data frame of all the columns. Similarly, for the second, it's a method which looks for the highest literacy rate in each continent. So basically working with I want you to explore working with data frames. I was thinking I should there are some kinds of navigations and operations that I forgot to add on to the questions, but basically there are 5 questions where you're going to work on the data set, creating methods, and working with the data frame object. Okay, so if I go back to my over here, so the examples I've given, I've created all the methods in the class as static methods. So when I call them using the class name dot and then provide whatever parameters I need to. Okay, and the last requirement that I've set is to draw a graph using the matplotlib library. So the 6th question, I'm going to say use any of those 5 methods. Use the data frame that is returned to generate a graph. And I've given an example of a fairly simple graph over here. Census.drawGraph, and the draw graph I have for the y-axis value. I go into the data frame, take the first row of data, the first 7 columns, and I use that to populate the y-axis values. The x-axis values are some years. So those are some operations that I would like for you to explore. I also have used this group by, which is actually very similar. So total, let me just very quickly review that. So if I so one of the methods that I have explored in the document, querying and creating methods, querying the data frame and creating methods, is for total births in a state for a particular year. So so I get the state name and I can do a sum operation. For this, you just refer the numpy. This is very similar to how I would apply the sum operation on a numpy array. I basically apply it on the births column and I sum it up. Now, if I wanted to get the total births by state, so there are for each of the 50 states, I have to group by the state name, and then I'm saying I'm applying an aggregate operation on this births column. So state name is the grouping, and I'm applying an aggregation on the births column, and over here I'm saying the aggregation can be a sum, a count. So there are a lot of different types of aggregations on the column. Here it is for summing, and I want to display it as total births in a particular year. So you can see when I run that, this is the result I get of the grouping operation. Okay, so I've already gone well beyond what I intended, so 35 minutes, but I wanted to cover all the different aspects of working with a data frame. I'll just stop, and if you have any questions, email me.